ISC Standard 12 Subject Physics Practical according to Indian School Certificate Examination 2021 Syllabus. Experiment number 4. Objective of the experiment is to find focal length of coaxial combination of two convex lenses not in contact. Apparatus required are two uprights for holding lens, two thin convex lenses, two uprights for holding needles, two pointed needles, and 1 meter scale for determining focal length of a lens by displacement method. Here two pins, pin O and pin I. The distance between them is fixed, greater than 4 times the rough focal length, such that for position A of the convex lens, real and inverted image of the pin O is obtained over the pin I, and the real and inverted image of the pin I is obtained over the pin O. Similarly, there is one more position for the same lens, position B, such that the image of the pin O is obtained over I, and the real and inverted image of the pin I is obtained over pin O. And here the distance between O and I is represented with a small letter a, and the distance between the lens position A and the lens position B is represented with the letter B. From the ray diagram, it is clear that small a is equal to V plus U and small b is equal to V minus U, where U is the object distance and V is the image distance. Here I go for the first observation of the lens A. In this setting, two pins are kept at a fixed distance of 85 cm from one another. The first pin, pin O, is at 0.0 cm mark on the meter scale. The convex lens is at 34.0 cm mark on the meter scale, and the next pin, pin I, is at 85 cm mark on the meter scale. The lens is adjusted in between the two pins so that tip-to-tip match is found of the pin I and the inverted image obtained of the pin O. And this lens position in between the two pins is the first lens position marked capital A. Now for the same setting of the two pins, we find the second lens position, that is position B of the lens, and here we find that tip to tip match is found, so there is no parallax. Now we record the position of the same lens but position B on the meter scale. Since it is the same observation, hence we verify the observations already taken, and that is the pin O at 0.0 cm mark on the meter scale. The second lens position is 52.2 centimeter on the meter scale. That is position B of the lens. And the pin I is at 85 centimeter mark. Here is the first complete observation for the convex lens A, where pin O position is 0.0, position A of the lens is 34.0, position B of the lens is 52.2, pin I position is 85.0. Small a is the distance between the two pins, that is 85.0 centimeter. Small b is equal to the distance between two lens positions, that is 18.2 centimeter. Focal length of the lens A using above formula is 20.28 centimeter. Let's go for the second observation for the lens A, where the two pins are kept at a fixed distance of 95 centimeter from one another, and the lens has been given the first position, position A, such that the tip-to-tip match is found. Hence, there is no parallax. Now we record observation. Here I find pin O at 0.0 centimeter mark on the scale. The position A of the convex lens is 28.3 centimeter and the pin I has the position 95 centimeter. Here is the same observation where the same lens has been given the position B and the tip-to-tip match is found. Hence there is no parallax. And now we move to record the position B of the convex lens. Let's verify the positions of the pins and position A of the lens. I find the pin O at 0.0 centimeter on the meter scale. The first lens position is shown here using the pin, that is 28.3 centimeter, and now the lens B position, now position B of the lens is 64.0 centimeter on the meter scale, and since it is the same observation, so the pin I position is 95 centimeter. Here is the second observation, second complete observation for the lens A. The position of the pin O is 0.0. The first position of the lens is 28.3 centimeter. The second lens position is 64.0 centimeter. The position of pin I is 95.0 centimeter. Small a equal to distance between the two pins, that is 95.0 centimeter. Small b equal to the distance between the two lenses, that is 35.7 centimeter. The focal length f using above formula is 20.40 centimeter. The mean focal length of lens A is 20.34 centimeter. Let's go for finding out the focal length of the lens B. I go for first observation for the lens B, where the two pins are kept at a fixed distance of 90 centimeter from one another, and the lens first position A, is given to the lens, and here tip to tip match of the pin I and the inverted image of the pin O is found. Now we take observations. The position of the pin O is found, that is 0.0 centimeter on the meter scale. The first lens position A of the convex lens is 30 centimeter, and the pin I position is 90 centimeter on the meter scale. Now I go for the same observation number to find position B of the same convex lens. But before that, we check that tip to tip match of the pin and inverted image is found or not, and it's found correct. Now we take observation. Here I find the pin O at 0.0 centimeter mark on the meter scale. Position A of the convex lens, as recorded earlier, is 30 centimeter mark, and now let's record position B of the lens, that is 59.9 centimeter mark, and you see the pin I is still at 90 centimeter mark. Here is the complete first observation for the convex lens B, where the position of the pin O is 0.0. The first position of the lens is 30.0. The second position of the lens is 59.9. The position of pin I is 90 centimeter. Distance between the two pins, small a equal to 90.0 centimeter. Distance between the two lens positions, small b, is equal to 29.9 centimeter. The focal length of the lens B, calculated by above formula, is 20.02 centimeter. Let's go for second observation for the lens B. I go for second observation for the lens B. The two pins are fixed at a distance of 100 centimeter from one another. The tip-to-tip match is found of the pin I and the inverted image of the pin O. It means the lens has given the right position A, on the scale. Now let's go for checking the positions of the pins and the first position of the lens, that is position A. I find the pin O has the position 0.0 centimeter on the meter scale. The lens position is 27.9 on the meter scale, and the pin eye position is 100 centimeter mark. We go for position B of the lens for the same observation. Now here the position B has been given to the same lens, and tip to tip match is found of the pin eye and the inverted image of the pin O. And at this stage, as I said, the image of the two pins are formed at one another. Let's verify other observations of the same observation number and then the position B of the convex lens. So here I find the pin O has the position 0.0 centimeter on the meter scale. The lens first position is shown here with the alpin, that is 27.9 centimeter. Position B of the lens is 72.1 centimeter, and the pin eye position is 100 centimeter mark. Here is the complete second observation for the second lens B, where position of the pin O is 0.0 centimeter. First position of the lens is 27.9 centimeter. Second position of the lens is 72.1 centimeter. The position of pin eye is 100.0 centimeter. Distance between the pins 100.0 centimeter. Distance between the two lens positions is 44.2 centimeter. The focal length of the second lens, calculated using above formula, is 20.12 centimeter. The mean f of the two observations is 20.07 centimeter. Finally, the focal length of the lens A is 20.34 centimeter, and the focal length of the convex lens B, that is the second lens, is 20.07 centimeter. Let's go for taking observations for the combination of these two lenses not in contact. Here is the ray diagram to determine the focal length of coaxial combination of two convex lenses kept at a fixed distance d from one another. Here coaxial means the principal axis of the two lenses fall on the same line. In this coaxial combination of the two lenses, OA is the object distance u and BI is the image distance v. The distance between the two lenses d is equal to 10 centimeter, kept fixed throughout the experiment. Now I go for taking observations one by one and recording them to find out the focal length of the coaxial combination of the two convex lenses. I go for the first observation. Here, two convex lenses are arranged at a distance of 10 centimeters from one another. Object pin and image locating pin are set. Tip to tip match is found, hence no parallax. Now let's check the position of these pins and lenses on the meter scale. I find the object pin at 10 centimeter on the meter scale. First lens 26 centimeter, second lens 36 centimeter, and the image locating pin is at 60.8 centimeter. Here is the first complete observation recorded in the table, out of which object pin position is 10 centimeter. The first convex lens position is 26 centimeter. The second lens position is 36 centimeter. The image pin position is 60.8 centimeter. 16 centimeter with minus sign is the value of object distance OA. Due to sign convention, the value U will remain negative. The image distance V is 24.8 centimeter. The distance between two convex lenses is 10 centimeter, and this value will remain fixed for the whole experiment, and that is the distance between the two convex lenses. The value of focal length of the combination of two lenses using lens formula obtained is 9.73 centimeter. Let's proceed and go for the second observation. Let's go for the second observation. Again, tip to tip match is found between the image locating pin and the inverted and real image of the object pin O, while refraction through the combination of two lenses separated at a distance of 10 centimeter. Let's check the position of pins and lenses on the meter scale. I find the position of the object pin on the meter scale at 8 centimeter. The lens A is at 26 centimeter on the meter scale, and lens B is at 36 centimeter on the meter scale, and the image locating pin is at 57.1 centimeter mark on the meter scale. Here is observation number 2 recorded in the table, where the position of object pin is 8.0, the position of lens A is 26.0, the position of lens B is 36.0, the position of image pin is 57.1. The object distance U is minus 18.0. The image distance is 21.1. The distance between lenses is 10.0. The focal length of the combination is 9.71 centimeter. Let's go for the third observation. I go for the third observation. The object pin position is changed and accordingly the image locating pin is adjusted to obtain tip-to-tip match between the image locating pin and real and inverted image of the object pin while refraction through the combination of two convex lenses. We check now the positions of pins and lenses on the meter scale. The position of the object pin on the meter scale is 6 centimeter. The position of lens A on the meter scale is 26 centimeter. Lens B on the meter scale is at 36 centimeter. And the image locating pin is at 55 centimeter on the meter scale. Here is observation number 3 recorded in the table, where the position of object pin is 6.0, position of lens A is 26.0, position of lens B is 36.0, the position of image pin is 55.0. These are the values calculated based on the observations taken, where object distance u is minus 20.0, the image distance v is 19.0, the distance between two lenses is 10.0, where focal length of the combination of two lenses is 9.74 centimeter. Let's go for observation number 4. I go for fourth observation of the experiment. The two pins and the combination of two lenses are placed well, and here I find the real and inverted image of the object pin O located by the image locating pin, because tip-to-tip match is found, hence no parallax. Now we check the positions of pins and the combination of two convex lenses on the meter scale. The object pin is at 4 centimeter mark on the meter scale. Convex lens A is at 26 centimeter mark on the meter scale. Convex lens B is at 36 centimeter mark on the meter scale. And the image locating pin is at 53.2 centimeter mark on the meter scale. Here is observation number 4 recorded on the table, where object pin position is 4.0, lens A position is 26.0, lens B position is 36.0, and image pin position is 53.2. Here are the values calculated based on the observations taken, where object distance u is minus 22.0, image distance v is 17.2, distance between lenses is 10.0, and the focal length of the combination of lenses using above formula is 9.65 centimeter. Let's go for fifth and last observation of the experiment. I go for fifth observation. Pins and lenses are set properly, and we observe tip to tip match of the image locating pin and the real and inverted image of the object pin. Hence, no parallax found here. Now let's go for checking the positions of the pins and lenses on the meter scale. The object pin is positioned at 2 centimeter mark on the meter scale. Convex lens A is at 26 centimeter mark on the meter scale. Convex lens B is at 36 centimeter mark on the meter scale, and the image locating pin is at 51.5 centimeter mark on the meter scale. Here is the fifth and last observation recorded in the table, where the position of object pin is 2.0, position of lens A is 26.0, position of lens B is 36.0, and position of image pin is 51.4 centimeter. Here are the values calculated based on the observations taken, where the object distance is minus 24.0, the image distance v is 15.4, the distance between the lenses is 10.0, and focal length of the combination of lenses using above formula is 9.38 centimeter. Here are the focal length of the combination of lenses calculated in 5 different observations, and 9.64 centimeter is the mean focal length calculated from a set of 5 different observations. Here are the results recorded at the bottom, where the focal length of the lens A calculated 20.34 centimeter, where the focal length of the convex lens A is 20.34 centimeter, focal length of the lens B is 20.07 centimeter. Finally, the focal length of the coaxial combination of two convex lenses is 9.64 centimeter, where distance between the lenses is 10 centimeter, and that is fixed throughout the observations. The experiment to determine the focal length of coaxial combination of two convex lenses not in contact is completed. I hope you could have understood the experiment very well through the way the experiment is demonstrated in the video. Thank you.